Hey everyone, my last video with the Shovelhead was the LM2 project where I was calibrating the carburetors, and right at the end of the video I noticed that the idle was starting to stumble and break up, and I had to give the motorcycle gas to keep it going. And I made a U-turn and I decided it was time to cut it short and try and get the bike home. I thought as long as I would just give it gas, keep the RPMs high, I would make it. I didn't know if it was a fuel issue, electrical issue, or what, but I didn't make it. Ended up doing the walk of shame. But now I got it home and it was time to investigate exactly what the problem was. And I already had my multimeter out because I had figured this was going to be an electrical issue, and I was right. But we're going to jump right into the troubleshooting for the charging system. Let's get started. And the battery, as I expected, was low. We're looking at 12.06 volts. I'm not going to work with this. I'm going to charge this just a bit. And I ended up putting this on the charger to 12.5 volts. And this is like a couple hours later, and I was very surprised. You can see I can barely hold the multimeter. But if you look here, we're looking at 13.2, and as I go and give it gas, you can see that it is in fact charged. I thought the charging system was dead, but the numbers are looking like the charging system is working. And based on the RPM, there's just no way that this bike wouldn't function. And I'm immediately thinking that this has got to be a heat-related issue, because right now I'm giving it RPM, and I only stopped because the meter's about to fall to seat. We're at 13.8. I need to make a better meter test mount for this. Here's my adapter cable straight off the battery I made just for my multimeter, mounted on the handlebars, and I'm going to wait overnight to retest this bike to make sure it's fully cooled. Let's go on the top left for notation. We'll see fully cooled at 1250 RPM, 14.3 volts. That's fantastic. And now down to 1100, a mild high idle, 14.3 again. But a couple minutes later, 1100 RPM is only producing 13 volts. We're seeing the voltage drop with a constant RPM. And now I'm going and giving it some gas, and as I increase the throttle, the voltage is going up, but it's just not performing like it did earlier. So we're seeing a decline here, and now I'm going to speed things up at 4 times the speed so we can watch the degradation live. And now we're looking at 1100 RPM, 12.7 volts is being produced now. So it's getting worse and worse. Eventually we hit a point where we're going to have ignition problems. We're starting to see that stumble when it hits around 1000 RPM, where the bike usually idles. And I'm giving it more gas, sort of repeating what happened on the road when the bike failed. Now we'll go through some revs. At 3000 RPM, it could barely do 13 volts. Keep in mind, on the road, it was also powering the headlight, the LM2 computer, and an oxygen sensor heater, so a lot more current was being pulled on the road. Then we'll leave off with a final number here. I managed to see that 1100 RPM, we're down to 12.5. So yeah, this is no good. Let's investigate what's going on here. My initial guess is that it's the voltage regulator, not only because it's 40 years old, but because the stator is brand new. I just replaced it in a previous video. But since the stator can look like this inside the bike, we're going to check it. I'm going to remove the voltage regulator, these 2 bolts here, to get it out of the way to gain access to the plug for the stator. And this thing is boiling hot. Remember, I'm checking the bike at fail temperature. So now I remove that regulator plug, and I'll set my meter to ohms, and I know this is going to be a very low resistance reading, so I'm going to check the resistance from my cable, and it's 2.3 ohms. Reading across the stator, we see 2.6, so we know we're reading about 0.3 ohms, and that's good. Checking any pin on the stator to ground, we see an open, and that's good. And just for completeness, I checked the other pin to ground, and that's good. Now connected to both pins of the stator, and my multimeter set to AC. I'm going to check the voltage at about 2000 RPM, and at 2000 RPM, I'm seeing 40 volts. That is just fine. We take a look here, and we see on my RPM gauge, it's about 2000 RPM. Very good. No job I do is complete without going to ace. Here's the original bolt, and here's the replacement bolt plated along with the new washer. My new regulator has arrived from JP Cycle. It looks identical to the old one and has a crimp fitting as well. We'll disconnect the old one. It's the black wire on the lower side of the breaker with this red wire here. The breaker looks a bit worse for wear, but it's still good. I snipped the connector off the end of the wire, and that allowed me to pull it through the cable ties to the front of the bike. With that wire now out of the way, we removed the entire unit from the motorcycle. An inspection shows that the potting material has broken down over the years, and this is designed to keep moisture out of the unit. So I imagine after a while moisture has gotten in and probably has damaged some of those internal components, which is why it stopped working correctly. The top looks good, as you'd expect, although the grounds look a bit oxidized, and we could see some wear, some cracking on these cables as well. So this is old, it's ready to go. The new one, by comparison, looks a lot better. The potting, obviously in perfect condition. The wires look good, ready to be installed in the bike now. So I'll start off just by laying in position on top of its mounting bracket and plug in the stator connector while I still have room to do so. I've dressed all the cables and loosely affixed the bolts so I can inspect everything. Now both of those bolts will be snugged down, putting this into its final position, remembering that these bolts are the ground for the regulator. So if the threads or the bottom of this is really dirty, it should be cleaned to remove any rust from the area. Final torquing for these bolts is done with the ratchet. I just estimated. I didn't make them too tight. There's not a whole lot of thread that matches up with the bolts, so I didn't want to strip anything out. We can see the cables all dressed in and cable tied, not laying on the engine or on the ground or under the bike or anything like that. The other cable comes out the bottom of the front and will go through the original cable ties to its original position, which is through here, up and around, and back to just under that breaker we see over here. And I'm now going to cut that cable to size and put some flux on here, and I'll show you why I'm putting flux on here. I'm going to take the crimp connector and put it on the cable, and then I'm going to spin it around and just try and evenly distribute that flux through the wire. And this is because I'm not simply satisfied by crimping this cable alone, because after I do crimp the end of this cable, I like to wick some solder into the top of the connector to ensure a solid connection. Both of these cables are reconnected to the breaker, and that's going to complete this job. For the rest of this evening, I'm just going to plug in the tender and top off this battery, make sure we're starting off with a full charge. Next day I plug in, we got 12.6, we're ready to do our test. Engine is just fired up, we're at our high idle right now. The headlight is off, we're looking at 14.46 volts, very good, and no different than what we saw last time. Right now oil pressure is still high because it's cold, but these were the numbers we saw before, and also the numbers we're looking for. We'll see what happens. Now warmed up a good time later, and we're at a lower idle, and we do see 14.38. Expected it to change characteristics a little as the regulator warmed up. Let's go for a ride. Just off throttle, and this is with the lights on, and we're seeing 14.33, so very good, and just accelerating through the neighborhood, through the gears slowly. Consistent voltage as we're off idle, and this is with the headlights on, looking good. Now right now I shut my headlights off, and we can see my idle's just a hair low, 14.37, and what I'm going to do is I'm going to go and lean over and turn my headlights on, and with the idle a hair low we are going to see it drop. But the thing is, if I just touch the throttle, just a hair, you almost don't even hear it change, it'll go right back up into the 14s. So this is fine. You see, just like that. It should be no surprise that when I launch, it's consistent 14.33. That seems to be, at this given outside temperature, what this one is doing. It's just saying consistent voltage and is holding it, doing exactly what it should now, and the bike is running better as a result of having this consistent voltage. Now, if you look closely, all of a sudden something starts to happen because the voltage starts to drop. That's only because the connectors on the voltmeter up front here came loose, and I just, at the next stop, went and plugged them back in, and everything's fine, and I was able to resume testing. But the testing was conclusive, and it showed that everything is now working just fine. So it turns out that a lot of potential problems on this bike were probably being masked if you didn't have a voltmeter to monitor it, and it was all due to the voltage regulation, which probably could have gone the other way and blown up my battery. But that concludes this video on the charging system of this AMF lowrider. I hope you found this video enjoyable, entertaining, and informative. Do me a favor, hit that like button down below, helps me out a lot when you do, and hit that subscribe button for more videos like this when they come out. When the next video in this series comes out, a link will be posted in the top right corner. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?